Hi everyone, welcome back to the channel. Today we are going to talk about frequency distribution. Here I have a dataset with students' names and marks and the corresponding bar graph. These kind of datasets are very common. But in frequency distribution dataset, we take numbers as quantity to be measured, such as number of people or number of items. Like in this second table. The second table lists particular marks obtained by specific number of students. In the first table, the quantity measured was marks, whereas it is number of students in second table. Wherever you are using numbers as the quantity, then it is called a frequency distribution dataset. Number of students is frequency. We can also make a bar graph for the same. This frequency distribution is termed as ungrouped frequency distribution. But as can be seen, this data is very difficult to tabulate. One have to write down numbers from 1 to 100 and then across them we have to list down the number of students getting marks. For example, 45 marks have been obtained by these many students. 46 has been for these many students. We have 100 rows. In this case, group frequency distribution would come in really handy. Here data is grouped into different classes. Like in this table, there are classes 0 to 20, 20 to 40, etc. Now I don't have to list down 100 numbers or I have 100 rows. I can just list down different classes. So each class here has a lower limit mentioned at the left hand side and an upper limit mentioned at the right hand side. For example, in 0 to 20, lower limit will be 0 and upper limit will be 20. And the difference between both the limits is called a class interval, which is 20 in our case. Now class interval in all the classes in a particular data set should be same. One cannot mention 0 to 20 class in one row and in the second row you cannot mention 20 to 30, which has a class interval of 10. If the first class interval that you are mentioning is 20, then every class should have a class interval of 20. The group data can also be represented by a graph. Though it looks like a bar graph, it is actually a histogram. What is the difference? It can be seen that the bars in the normal graph has ample amount of space between them, but this space is negligible in a histogram. Now another thing I want to mention with this class interval data is that you can see few numbers like 20, 40, 60, 80 are present in two classes. Okay, like 20 is mentioned in 0 to 20 and 20 to 40 both classes. Now this creates confusion. Suppose a student has obtained 20 marks. So in which class should we count the student? 0 to 20 or 20 to 40? To eliminate this confusion, one has to avoid the repetition of such numbers. So we generally use the table like this. Now another kind of frequency distribution is cumulative frequency distribution. Now here, frequency of the previous row is added to that of the present row. Like in this case, the first row will remain 0, but the second row frequency will be the sum of previous frequency 0 and the present frequency 5. So the same thing will go for the third, fourth and all the rows. The graph generally plotted for this is a line graph. Since frequency keeps increasing with every row, the line graph also keeps going upward. So what exactly is the use of cumulative frequency, you might ask? It helps when a number higher or lower than a particular number has to be found. Now suppose I have to find out students with marks are smaller than 40. One way to go in the case of normal table is to add up the numbers until we reach the number 40. But in cumulative frequency distribution, there is no need of summing up the numbers. We can just go to the table or graph and we can see the second row of table or the second point in the graph, and the answer would be instant, that is 5. Similarly, if I have to find the number of students getting marks from 60 to 100, then I can either subtract the last and the third row frequencies from the table, or I can do the same with the graph to get the result 15. Of course, this seems to be easy in this case, that we don't have to use cumulative frequency distribution. Normal frequency distribution will also give easy calculation, but in large data sets, this cumulative frequency distribution, it makes the job really easy. So that's it for today. Thanks for watching. If you learned something, then like, share, subscribe to the video.